All right, problem number 13 is this center one right here. I'll give you a moment to go and find that.
13, right?
Yep, 13. On problem number 13, we need to find the value for x and the value for y. Let's find x first. So x is this angle right here. That is almost a full circle. It's a full circle except for this little bite that's been taken out of it, and we know how big that bite is. It is 96 degrees. So if I take x and I add 96 to that, it would give me a full circle, 360 degrees. So then I need to subtract 96 from both sides. And what is 360 minus 96? 264. So x degrees equals 264 degrees. So x is 264. What kind of an angle is this 96 degree angle here? We have 4 different kinds of angles that we talked about here. We had inside angles and outside angles. We had inscribed angles and central angles. What kind of angle is the 96? What kind of angle is this? Close. The vertex is inside, but the vertex is very specifically on what in the circle?
The radius or the intersecting point of the radius?
Where's the vertex? No, y is not. I'm looking at this angle right here. I want to know where the vertex of that 96 degree angle is. It is a central angle. This right here would be a central angle. It's a central angle because its vertex is right at the center of the circle. So how big would this arc right here be that it is intercepting? (96 degrees), yes. A central angle and its arc will have the exact same measurement. We need to find the measurement of angle y here. But I needed that 96 degree arc because that is the arc that angle y is intercepting. What kind of angle is angle y? Angle y is not an inside angle. The vertex is not inside the circle. It is inscribed because the vertex is on the circumference of the circle. And the rule that we have for inscribed angles is that the measurement of the angle is equal to 1/2 times the measurement of the arc that it intercepts. Our angle is y degrees, so that's what I'm going to put in for the angle over here. So y equals 1/2, and then how big is the arc that it's intercepting? 96 degrees. So I need to figure out what half of 96 is. That's how big y is. 48 degrees. If you don't already know the 4 different types of angles, what they look like, and what their formulas are, you are going to have to know that for tomorrow. Central angles, the arc that it intercepts has the same measurement as the central angle. The vertex of the central angle has to be right at the center of the circle. If it's anywhere else inside the circle except for the center, then we call it an inside angle. Central angles would be special kinds of inside angles. 24, absolutely. That's the very last problem in the entire packet. So I'm going to do this one in two pieces. There's a whole bunch going on in the picture. And so when I get to the point where I'm going to erase stuff off the picture, I'll let you guys know. I just don't want to get too much going on in the picture all at once. We need to find x and y, the measurement of arc JK, and the measurement of arc LM. So where do you see x? 3x plus 5, and you said angle K, which is 4x minus 6. 3x plus 5 is the measurement of angle J. And so I'm going to trace over that angle here. So here's angle J. And the other x is part of angle K, which is this angle right here. Notice that they both intercept arc LM. Their endpoints are at L and M for both angles. If two inscribed angles intercept the exact same arc, what does that mean about those angles? They are congruent. So the measurement of angle J is equal to the measurement of angle K. Angle J is 3x plus 5. And angle K is 4x minus 6. So now we're going to solve this for x. That means the first thing I need to do is get my x's to the same side. So I'm going to minus 3x from both sides. Over on the left, I would have just a 5 remaining. On the right, I have 4x minus 3x. That's 1x. And then I bring down the minus 6. Then we add 6 to both sides to get the x all by itself. And we get that x is 11. What is the arc that both of those angles are intercepting?
Wait, what was the question?
What is the arc that both angle J and angle K are intercepting? LM. That's one of the things we're supposed to find here. So let's go ahead and find the measurement of arc LM. What kinds of angles are J and K? They are congruent. But what of the 4 types that we talked about? Are they central angles? They're inscribed angles because the vertex is right here on the circumference of the circle. So this is an inscribed angle. The measurement of an inscribed angle is equal to 1/2 the measurement that the arc it intercepts. So I have to pick one of those 2 inscribed angles that are intercepting arc LM. So I'm going to go with angle J. I could do angle K, but I'm going to pick angle J. Either one of these is going to get the exact same answer because those 2 angles are the exact same size. So this is angle J equals 1/2 times the measurement of arc LM. And angle J is 3x plus 5. So 3x plus 5 equals 1/2 the measurement of arc LM. How big is x? 11. So I have 3 times 11 plus 5 equals 1/2 times the measurement of arc LM. 3 times 11 is what? 33 plus 5. 38 is equal to 1/2 the measurement of arc LM. How do I get rid of that 1/2? Multiply both sides by 2. Multiplication gets rid of fractions. If you do it to one side, you have to do it to the other. My denominator cancels out with that 2. What is 38 times 2? So 76 degrees is the measurement of arc LM.
Can we use K?
You could have used angle K, yes. You just have to pick one of them to use. You're going to get the same measurement for angle K that you do for angle J, because they're congruent angles. So far, so good? Oops, sorry, that was not supposed to flip. Still not working. Good gracious. All right, I'm going to go ahead and erase all the markings that I have on the circle so that we can do the rest of this problem. You guys okay with that? Okay. So that's how we found arc LM, and we found the value of x. Next, we need to find y. Where is y?
L and
Angles M and L. So angle M is this angle right here. What arc is that angle intercepting? JK. Angle L is this angle right here. I'm going to do that in purple, actually. What do you notice about angle L? Intercepting the exact same arc. It's also intercepting arc JK. So what does that mean about those two angles then? They are congruent. So angle L is congruent to angle M. Angle L is 6y plus 3. Angle M is 7y minus 1. We're going to solve this for y now, so I need to get my y's to the same side. So I'm going to minus 6y from both sides first. So I get 3 is equal to 7y minus 6y leaves me with 1y. And then to isolate y, we add 1 to both sides. And so that means that y is 4. To find the measurement of arc JK, I have to take one of those two angles, either L or M, and I have to use that to find the arc. What kind of angles are L and M? Inscribed. So because it's an inscribed angle, we have measurement of the angle is equal to 1/2 times the measurement of the arc that it intercepts. Do you guys want to use angle L or angle M? It doesn't matter. We're going to get the same answer either way. Do you want to use L or M? M sounds good. So the measurement of angle M is equal to 1/2 times the measurement of arc JK. Angle M is 7y minus 1. It's equal to 1/2 times the measurement of JK. And we just found out that Y is how big? 4. So I have 7 times 4 minus 1 equals half of arc JK. What is 7 times 4? 28 minus 1. So I have 27 equals half of arc JK. And then I need to get rid of that 1/2 on the other side. Multiply. Multiply by what? Multiply by 2 because my denominator is a 2. So my denominator cancels out with that 2 that we multiplied by. 2 times 27? 54 degrees is equal to arc JK. Nice work. 23? Absolutely.
Wait, which one?
23. We're just going up one problem. What? Not really. A lot of people say ankles are really painful. I didn't think it was that bad, but yeah. All right.
You said physical?
Ankle. They'd be very committed to their job, more committed than I am. All right. Let's go ahead and add the information that they gave us. Angle B is 102 degrees. Angle D is 7x plus 1 degrees. Angle A is 4y plus 14 degrees. And angle C is 7y plus 1 degree. When I have a quadrilateral, which is what this is, it's a four-sided shape, inscribed inside of a circle, opposite angles are supplementary. What does supplementary mean? There we go. Opposite angles add to 180. What are some pairs of opposite angles in this shape? Which ones? D and C are not opposite angles.
Or A and C?
A and C. So angle A plus angle C equals 180. What's the other pair of opposite angles? B and D. So the measurement of angle B plus the measurement of angle D equals 180. How big is angle A again? 4y plus 14. And angle C? 7y plus 1. Add those together, set it equal to 180. We're going to combine our like terms. I have a 4y and a 7y that'll combine to give me what? 11y. And then we have 14 and 1 that combines to give me 15. Equals 180. And so then I'm going to subtract 15 from both sides. You said 165? All right, so 11y equals 165. Then I'm going to divide both sides by 11, and we get 15 for y. Nicely done. And so now I need the measurement of angle B. 102 plus the measurement of angle D, 7x plus 1, equals 180. I only have two like terms over on the left. I have the 102 and the 1. What's that going to combine to give me? 103. 7x plus 103 equals 180. Then I'm going to subtract 103 from both sides. How much? Sorry, I didn't hear. 77. 7x equals 77. Thank you. What?
The first answer, you give the value of 11, will give you the answer, and now 11.
It's an interesting coincidence. X equals 11. All right, now we need to find two arcs. We need to find arc BCD and arc ABC. Which one do you want to find first? BCD sounds good. So start at B, pass through C, and then come around to D. So this is the arc that we want to find the measurement of. What angle is intercepting that arc? No. C is part of the arc. What angle is intercepting the arc? A. This right here, because AB, B is one of the end points of my arc, and it's the end point of that segment. And then AD, D is an end point of my arc, and it's an end point of this segment. So angle A intercepts arc BCD. What kind of an angle is angle A? Inside, outside, central, or inscribed? Inscribed. And again, it's an inscribed angle because its vertex is on the circumference of my circle. So the measurement of the angle is equal to 1/2 times the measurement of the arc. So we have measurement of angle A is equal to 1/2 the measurement of arc BCD. How big is angle A? 4y plus 14 is equal to 1/2 arc BCD. And how big did we say y was? Y was 15. Sorry, I just couldn't hear. Y is 15. So 4 times 15 plus 14 equals 1/2 of arc BCD. What is 4 times 15? 60 plus 14. So we have 74 equals 1/2 times the measurement of arc BCD. And how do I get rid of the 1/2? Multiply. We're going to multiply both sides by 2. 148. So 148 degrees for the measurement of arc BCD. All right, we still need to find ABC. So I'm going to go ahead and erase the orange markings that I have on this circle. Arc ABC. A around to B and then over to C. What is the angle that is intercepting that arc? A is not intercepting arc ABC.
I mean D.
D, right down here. Because D goes over to C, which is one of the endpoints of my arc. And D also has a segment that goes to A, which is the other endpoint of my arc. So angle D intercepts arc ABC. What kind of angle is angle D? Inscribed angle. Its vertex is on the circle. So the measurement of my angle is equal to 1/2 times the measurement of the arc that it intercepts. So the measurement of angle D is equal to 1/2 times the measurement of arc ABC. How big is angle D? 7x plus 1 equals 1/2 times the measurement of arc ABC. And what is x? 11. So I have 7 times 11 plus 1 equals 1/2 times the measurement of arc ABC. What is 7 times 11? 77 plus 1. So I have 78 equals 1/2 times arc ABC. And to finish solving this for ABC, multiply both sides by 2, 156. All right, what else would you guys like to see? 15 and 22, sounds good. We'll do 22 since I'm right there, and then we'll go back and do number 15, absolutely. All right. So 22, top of this back page. First thing it tells me is that segment AB and segment AE are tangent to circle C. So when segments are tangent, they form right angles with the radius of the circle at the point of tangency. So where does segment AB touch the circle? Where does segment AB touch my circle? At point B, right here. So that is where the right angle is, angle ABC. AEC would be the other one, yes, because that's where that tangent touches my circle. So ABC and AEC. Nice work. All right, and then I don't know why that was marked as B when there's nothing there. This is point B, or this is question B. Yes, you can. We want to use the measurements given on the diagram to find the following three lengths, AE, AC, and AG. When I have two segments that are both tangent to the same circle, when Carlo gets back, two segments that are tangent to the same circle, and they have this common exterior endpoint, those two tangent segments are congruent to each other. It says that segment AB is how big? 24. So how big is segment AE? Also 24. Next thing we want to find is segment AC, which is this segment right here. What is this shape right here? What kind? A right triangle. Remember, we started off at the beginning by naming that right angle. And I want to find the length of AC. What can I use to find the lengths of sides of right triangles? Pythagorean theorem, yes. A squared plus B squared equals C squared. What are we going to put in for C? Look.
I'll put AC.
We put AC in. Why do you put AC in? Why did you put it?
It just makes sense that way.
Okay. What do we always have to put in for C? What part of a right triangle goes in for C? The hypotenuse. And how do we locate the hypotenuse in a right triangle? Across from the right angle. Well, here's my right angle. The side that is opposite that is this side right here. So AC is my hypotenuse. So what would we put in for A and for B? 7 and 24. Does it matter which goes in where? Nope. So put 7 in for one of them and 24 in for the other. And now we have to square both of those. What is 7 squared? 49. 24 squared?
Well, 576.
576. And then I have to add those two together. 625 equals AC squared. What do I still need to do? Square root it. What is the square root of 625? 25. So AC came out to be a nice whole number. It is 25. Last thing they want me to find is AG. So I know that this whole thing here is 25. I want to find just this much of it. How big is GC? Yes, we do. It is 7. Why is it 7? Because it's a radius. They tell us right here that segment BC from the center to the edge is 7. So any other radii would also have to be 7. So GC and CE would also be 7. Segment AG plus segment GC, if I put those two together, it gives me segment AC. You guys just told me that GC is how big? 7. And we found a moment ago the size of segment AC, 25. So then we subtract 7 from both sides. And AG is 18. You said 15, right? Awesome. We're going to go to problem number 15. That's one of the ones in the boxes on the back side of this. Number 15, we need to find x and we need to find y. Let's find x first. This is x. What part of the circle would we call that? It's not a chord. Chords have to be straight lines. This is an arc. So I'm going to look for an angle that is intercepting this arc. Is there an angle that is intercepting the arc that's marked with x? 30. There's another angle too, but this is the only one that has a measurement on it. It is 30 degrees. What kind of angle is this? It's an inscribed angle, the one with an arrow pointing to it. Thank you, sir. So we're going to use our formula for an inscribed angle. The measurement of the angle is equal to 1/2 times the measurement of the arc that it's intercepting. How big is the angle that is intercepting our arc? 30. So we're going to put 30 in the place of the angle here. Equals 1/2. And what's the arc? X. So 1/2 times x. I need to get rid of that 1/2 so that I have the x all by itself. Multiply by 2. And what is 30 times 2? 60. So x is 60. And then we need to find y. Is y another arc? No. So what is y? It's an angle. What kind of an angle is it? It's another inscribed angle. What is the arc that it's intercepting? 98. So the measurement of the angle is equal to 1/2 times the measurement of the arc that it intercepts. How big's the angle? Y. The angle is y. Equals 1/2. Now how big is the arc? That's the one that's 98. I don't have any variables over here on this side. It's all numbers. When Sydney gets back. So I can pop the right-hand side into my calculator. What is 1/2 of 98? 49. So y is 49. What else do you guys want to see? You said 16? 23? Absolutely, I can. So 16 and 11. There's 23. Yeah, I was asked to go back to it. We're going to do 16 next. You good, Kennedy? Okay. Oops, there we go. 16. We want to find the measurement of arc FG and the measurement of angle E. Angle E first? Actually, yeah, we could do that. We can find angle E first. So this is the angle we're looking for. I don't know how big that arc is. That's the arc I'm looking for. So I'm kind of stuck right here, but I know all three angles in a triangle add up to what? Adds up to 180. I know angle G is 71 degrees. Do I have any other information on this picture at all?
Yes.
What do I have? 146, which is this arc right here. 146 is not half. Oh, okay. Ah, yes. What angle is intercepting this arc? F. FE and FG go to the endpoints of my arc. So angle F intercepts this arc. What kind of an angle is angle F? Inscribed. Its vertex is on the circumference of the circle, so it's an inscribed angle. So the rule that we have for inscribed angles is measurement of my angle is equal to 1/2 times the measurement of my arc. We don't know how big angle F is. Measurement of angle F is equal to half of, how big is the arc it's intercepting? 146. What is half of 146? 73. So angle F is 73 degrees. I know they didn't ask me to find angle F, but I needed to figure it out so that I can find angle E, because I know that the three angles in a triangle add up to what? They add up to 180. So I'm going to take 73 plus 71 plus the measurement of angle E equals 180. What is 73 plus 71? 144 plus the measurement of angle E equals 180. Yep, we're going to subtract 144 from both sides, and you get 36 degrees. You do not have to find angle E first, by the way. Once I know how big angle E is, do I have enough information to find arc FG? Because angle E is what kind of angle? Inscribed. So the measurement of angle E is half the measurement of arc FG. We know that angle E is 36 degrees. So then we multiply both sides by 2, and we get 72 degrees. All right, number 11 is the next one that we're going to do. Just set it right here. Yeah, just set it in the same spot. All right, number 11. You're welcome. Determine if segment LN is tangent to the circle. Tangent lines do what where they meet the circle? They touch. They form a 90-degree angle. So if it's tangent, then that'll be a right angle there. But I don't know if it's a right angle. That's what I'm trying to figure out. If that's a right angle, then it's tangent. If that's a right angle, then this would be what kind of triangle? It'd be a right triangle. So we're going to use Pythagorean theorem. A squared plus b squared equals c squared. I don't know that this is going to come out equal. I'm checking to see if it comes out equal. And if it does, then ln is a tangent. Which piece of this would be the hypotenuse if that really is a right triangle? 39. So that's what we're going to put in for C. So I have 39 squared. I don't know if that's equal to, so I'm going to put a question mark here. What would go in for A and B? 15 and 36. Order doesn't matter on this part. What is 15 squared? 225. 36 squared? 1296. What about 39 squared? 1521. What do we get when we add 225 and 1296? 1521. Did my two sides come out the same? So what does that mean? It is tangent, yes. So I would say yes. Ln is tangent to circle M. Because segment Ln is perpendicular to the radius MN. We have 9 more minutes until the bell that releases D-Lunch. So I'll answer another question, maybe 2, depending on how long or how short they are. After that, you guys are welcome to come up and ask me questions individually. No, equal is not the same thing as perpendicular. Number 5, absolutely. Number 5, yep. All right. We have circumference, diameter, and radius stuff. So we have 2 formulas that are going to be useful here. Circumference is equal to pi times the diameter, or that's exactly the same thing as saying the circumference is equal to 2 pi times the radius. These are formulas that you have to know. You don't have to memorize both of them. If you remember one of them, you can use that to find any other pieces. But you have to know your formulas for angles, and you have to know the formula for circumference. All right, so for part A, we have the circumference. So I have C. We want to find the diameter and the radius. So I'm going to go ahead and use pi d. We'll find the diameter first. I could use 2 pi r. There's nothing wrong with that. The answers come out exactly the same. We're going to put 53.5 in the place of C. And then what would I need to get D, the diameter, alone? Divide both sides by pi. Use the pi button on the calculator. What is 53.5 divided by pi? $17.029 or 03, I think, because the next number's a 9, right? Yeah. So we'll call it 03. Do we have units with that? Centimeters. So here's my diameter, 17.03 centimeters. Once I know the diameter, how do I find the radius? Yes, cut it in half. Radius is equal to the diameter divided by 2. So I'm going to take 17.03 and divide that by 2. 8.515. We're going to put centimeters with that also. You put 8.5? That's fine. 8.52 is fine if you round that up. It says round to the nearest hundredth, which is 2 decimal places, so that'd be perfectly appropriate. Part B, I know the diameter. I need to find the radius and the circumference. Which one would be easiest to find first? Radius. Radius is equal to the diameter divided by 2. How big is my diameter? 12 divided by 2 gives me what? So the radius is 6 centimeters. And then we find our circumference. Circumference is equal to pi times the diameter, or you can do 2 pi r. Since we just found r, you could do it that way also. How big's our diameter? 12, so pi times 12. If I wanted to leave this in its exact form, I would say 12 pi centimeters, but they asked us to round our answer, so I'm going to put 12 pi in my calculator, hit enter, and then how do you get it to show you the decimal? The arrows right above the enter key, those back and forth arrows. What is 12 pi in decimal form? 37.7 or 0.699. All right, very quickly, before I set you guys loose, I have already posted the answer key for this. It is up in Canvas. To get to it, thank you. From our Canvas homepage, you're going to click on Modules in the left-hand navigation tab. Sorry, Jada, I didn't see you there. I thought I heard a knock and then I didn't see anybody. So you click on Modules. You want to scroll all the way until you see today's date, Tuesday, March 26th. The answer key won't just be listed there. You have to click here where it says Review for Module 10 Test Day 2. When you click on that page and then you scroll all the way to the bottom of the page, Geometry Module 10 Test Review Solutions. If you click on that, there's a PDF that has all of my work color-coded so that it's hopefully easy to follow. If you guys have any other questions, please come up and see me during the D lunchtime, or if it's after this class, you can always send me a message through Canvas.